Okay. So here's what you need to know about polar coordinates. I promise this is really hard. Okay. This is your usual XY plane kind of idea, right?
Cartesian plane.
Yeah.
Yeah, so that's Cartesian coordinates, right? So how do you tell your buddy to go to a point?
You
Over X, up Y.
Drop a pin and then text it to him.
Drop a pin and then text him the coordinates.
get your location.
Exactly. So when you text him those coordinates, your method for texting coordinates in this class has so far been you go left or right by X units, and then you go up or down
By Y units.
by Y units, right?
Y.
Units.
So this is the point X comma Y, right?
Yeah.
Okay. If you dropped a pin in an alternate coordinate system,
Okay.
there would be other ways to describe how to get there. For instance, we could do something silly and confusing and declare that to be the first coordinate
Okay.
and then that to be the second one.
Okay.
Would that be different in any way?
Yeah, it's not
No, it would
square.
just take a different.
As long as you're not a square.
It would be weird, right?
But you travel the same amount of distance.
But you would travel the same distances and there would be a reasonable way to communicate how to get someplace, right? Instead of saying, okay, so you go to the right 3 units and then you go up 4 units, you would say, okay, so you go up 4 units and then you go right 3 units. Right? Those are comprehensible directions. So instead of doing overs and then ups, what if we instead did, right, so I'm putting overs and ups
Okay, so
on the floor of the classroom, right?
Forward steps and left steps.
Yeah, so what if I instead did turn and then walk?
Okay, so you create an angle theta and then walk.
Yeah, so we're going to make an angle theta. That would be this guy.
That's pretty cool. Makes sense.
And then we're going to make a distance to walk, which we would call
R.
R. And then alternatively, right, instead of calling this a point x comma y, I might call it a point r comma theta.
No. R theta. Seen that somewhere.
I've seen that in maybe like a previous.
In like a previous class, like maybe a trig class.
On the street.
Yeah, exactly. So, how do you know whether a point is in polar or Cartesian?
So what was that?
How do you know if a point is in polar or Cartesian?
Well, polar is R theta and Cartesian is
X.
Y.
Sure, so is 2 comma 3 right
Cartesian.
2 up 3,
Yeah.
or is it go 2 units after going to the angle
Pretty sure theta,
3?
you have to say degrees in your polar coordinates. No. Or radians, yeah, something like that.
Isn't it always radians?
Okay, so
Isn't it always a
it should be noted that theta is in radians
6? So
unless otherwise specified.
okay, like not milliseconds or whatever.
Always.
Okay, remember that.
Always is, unless it's
Minute,
never.
second, like rotation on minutes.
Okay.
Yeah, okay, so you may put degrees in there. Please, for the sake of confusion, for the sake of clarity, do not put minutes and seconds in your degrees.
One
Yeah, that would
degree
mess
minute,
me
second.
over.
Okay?
That would mess me over.
Use degrees, decimal degrees if you must use degrees.
No way. Radians all the way.
Deci degrees?
Yeah,
Rad
Can you use decimal radians?
Can you use decimal to radians?
yeah.
Okay, let's just move forward.
Okay, anyway. How do you know whether it's 2 comma 3 in x and y or 2 comma 3 in r and theta?
Oh, you know what? I have no idea.
Yeah, you just don't.
Well then.
It's really unfortunate. This is one of those things that just depends on context.
I thought we were getting
So
better
it's just
at
context of the problem.
Yep. So I'll tell you that a point is in polar or Cartesian
And there's ways to
on
convert
tests,
between.
and there are ways to convert. So the first thing we should do is maybe make conversions. So what are your conversions?
I don't remember.
What do you mean?
Okay, look at this picture. Here's an x.
Dude, it's gonna be a tangent, whatever.
Okay, something's going to be a tangent.
Yeah, well, it's gonna be slope is tangent, right?
Okay,
And
the
then your
slope
r
is
slope.
tangent.
And then your x and y is your rise over run. It's just,
So you're telling me tangent of theta should be y over x?
that's exactly what it
No, yes.
Because it's the opposite over the adjacent?
is. Yep.
Well, it is if this is a right triangle. Is that a right triangle?
Should be.
It looks like it, but I can't just assume.
You can just
No,
assume.
you can because the right.
Because
because
they're
y is
overs
vertical.
and
Yeah,
ups,
y is
right?
That's what I was
Yeah.
trying to say. Everyone talked over me.
Okay, so one conversion factor is theta is the arctangent of y over x. That will get you a way to convert from Cartesian to at least the theta part of polar.
Rock on.
Where do you get the r part of polar?
You can get it through Pythagorean.
Cool. You can get the r part of polar from the Pythagorean theorem. So you can do the square root of x squared plus y squared, and that'll give you r.
Oh, that's right.
You guys see that one?
I remember this.
Pretty clearly.
I
X
remember
squared
writing
plus
this
y squared
down
is r
in
squared.
gym class.
Okay, now the other two. So these guys, by the way, are the Cartesian
To polar.
two polar ones.
Polynesian coordinates.
These other guys are going to be the polar to Cartesian.
Polar. Jean.
Where are you going to get the polar to Cartesian ones?
Oh man, so if you have theta.
In other words, if you know r and theta, where do you get x and y out?
Dude, you just
You just do the reverse.
inverse ops.
No.
No.
Don't do the reverse operations, they'll be annoying. If you imagine knowing these two,
Yeah.
right, like if this is 17 degrees and this is 7,
Yeah.
like we
So-
did earlier,
So do you just do the cosine,
yeah, the cosine's going to be which one?
the x,
X.
and then sine is
X.
gonna be the y.
So x is, oops, not 7. X is r cosine theta. Why's the r in there?
Whoa. Okay. so
Because
X
that's
R cosine.
oh.
Because you multiplied out the original.
Yeah.
Because cosine theta equals y over, x
X
over
over
r,
R.
and you,
Multiplied by.
Yeah, so I said the cosine is the adjacent over the hypotenuse. That's an x over r, and then I multiply both sides by r. So the y then is r.
X cosine theta,
Y cosine theta.
like r cosine theta.
Y equals R sine.
Totally
Oh,
what I meant.
I mean, yeah.
Sine. Oh, okay.
Okay, it's sine because it's the opposite side, right? And then the hypotenuse is r.
Got it.
Cool.
I'll get there.
No worries. Okay, so there's your conversion factors between polar and Cartesian. Cool? Questions, things on this? Okay, it is worth noting that there is one little weird thing.
Of course.
Oddness.
As opposed to
Let's talk about a little bit of oddness.
Oh, yeah, so I don't mean this in, maybe I should call this strangeness.
Stranger Things.
There's one strange thing here.
Strangeness.
What's the strangeness about 0?
Yeah, well, X is 0, then
X is 0, then
so you can't
If x is 0, then the arctangent part would be undefined, right?
you can't use these formulas to convert a vertical line into polar.
Close.
Vertical. Horizontal.
vertical lines have a theta of 0.
Horizontal.
Yeah, you can't use this conversion factor, right? This conversion formula
Oh, because
doesn't work on, it's not all vertical lines.
It doesn't work when theta is 90 degrees.
Yeah, it doesn't work when theta should be 90 degrees, right?
Okay.
You guys see that? So it doesn't work for things that are straight up or straight down. Those ones you have to kind of imagine, right?
Okay.
You guys see that? So if you have points that are on the y-axis, right, their theta is not going to come out of that formula. You're going to have to think about it for a second. What about at 0, 0?
Everything.
Then
Everything's
you
zero.
don't need to go anywhere. Why do we even care?
You're in the Genesis, man. You're at the origin.
Okay, yeah, you don't have to go anywhere,
That's so funny.
but what's the polar coordinates for 0, 0?
0.
Like, so here's a dot,
Zero,
right?
infinity.
Cartesian, 0, 0.
Mhm.
Polar,
Is not 0, 0? Is it like 0, infinity?
well, definitely you're not going anywhere, right?
It'd be zero anything.
So it's 0 and then,
Any degrees.
yeah, this could be whatever, right? Because, sure, right? If you start at the origin and you spin around and then don't go anywhere, doesn't matter how much you spun around,
The
it's still the
point's
same point. You guys see that?
They want you to be facing in a specific direction.
Yeah, so there's a little bit of weirdness when R is 0. Then it can be whatevs. And then it should also be noted that if you make theta like 4 pi,
Okay.
right,
Yeah.
then what?
You go around.
So if you're talking about the point in polar 2 comma 4 pi,
Well,
Then you're actually dealing with.
so you're just going around the whole thing.
You're just going around the whole thing twice, and
With
then
a
your x is
radius
going
of
to be
2.
0.
So, yeah,
Or
exactly.
your
so
y
these
is
2
0.
points are actually the same point, right? So that's one of the strangenesses about polar, is there's some weirdness with conversion when you're talking about theta is pi over 2 or minus pi over 2. There's some weirdness when R is 0, and then there's some kind of fuzziness about coterminal points.
Cool. To the
You guys cool with that?
Exactly.
Okay, so those are limitations. But this thing draws circles really, really well.
Yay.
What's the equation of a circle?
The equation of a circle is pi times.
Yeah, so I want this circle, centered up at 0, has a radius of 2.
Circumference of a circle is pi times.
No, I want the equation of a circle.
God.
X squared plus y squared equals 1.
That's a unit circle. So in Cartesian, this would be x squared plus y squared is 4. Right, x squared plus y squared is r squared.
Yeah.
But in polar, to get to points on that thing, where do you go from the origin?
You can go at a specific. You go 2 from the origin.
Yeah, you go 2 units in any direction at all, right?
Yeah.
So that would be r is 2 in polar.
Yeah.
You guys see that? So if you're thinking circles, polar is the way to be.
Oh, because all you have to say is that r is
'Cause-
2, and that's the equation of the circle.
Yeah, all you have to do is specify the radius.
Wow, that makes a lot
They'll
of
just
sense.
specify the origin.
And the origin's always
The origin's the origin, man. You don't specify that in Cartesian
I mean,
either.
center of the circle.
That's the origin.
If it's moved, did you like shift?
Yeah, so if you move it, things get weirder. Right, same as they do in Cartesian. If you move it in Cartesian, they get even weirder. So there's some shifting rules that might apply. Cool? Questions, things? Okay.